Welcome, everybody. It's been a long day. I'm sure everybody's enjoyed zooming out today. I know I always like seeing different perspectives, especially from different folks around the country that have been working on different things. At the end of the day today, we decided to do something on teaching sustainability and energy literacy to technicians and how we handle it in two different versions of two different makes of class. My name is Bob Clark. I'm from the College of DuPage, the department chair for HVACR. And we have Ted Wilinski here, which is a co-PI. He's introduced himself multiple times today, but he is in charge of automated building systems over at MATC in Milwaukee, Wisconsin. One big thing I think that that probably disturbs any educator when it comes to HVACR is, where do I put this in my curriculum and the time? And to me, it aligns no differently than with soft skills. It's a lot of folks that don't do soft skills as much just because they don't want to make an entire class for it. And it's one of the only answer I've ever found that has ever worked for any of these things, just like energy, sustainability, soft skills, is integrated into every part of all of the curriculum in little bites over time. And we're going to kind of show you how we do it in both of our programs. And to start this off first, and we were thinking about having questions at the end. We'd like to hear some examples from everybody, you know, what works for them, or maybe some ideas just to kind of share with. But we also have assignments and different examples of different things that we use, you know, to kind of bang these points home about sustainability and energy in the classroom. So to carry on and move this discussion forward, I'm going to let Ted take over here, kind of show how he works with it with automated building systems.
Thanks, Bob. Yeah, so one of the things, this is a facilitated discussion, and we're going to try to get through our slides before we start interacting more. So we might just wait and hold off for questions or discussion at that point, like Bob mentioned. So the typical statement for sustainability environment, it started, if you think about it, it's our motto to be environmentally sound, right? And a lot of this, anybody who came through the Depression knows, which obviously probably none of us here have, but my parents did, and I'm sure quite a few other people's parents had. But with the increasing population, it's gotten more and more difficult, and so we have to do more with it. Everything we do must include sustainability and energy conservation. If you just think about your daily lives, what you do, we think more about it today than we did 5 years ago, 10 years ago, 20 years ago, 30 years ago. One of the things that I have found over the years that has impacted energy conservation is, once you start looking at nipping away at all these edges to reduce consumption, these things have a domino effect that impacts your energy consumption and health in other areas. It just really comes and collapses the consumption pattern so that it works together. Whereas you work on these things in individual silos, they don't have as much of an impact, and they can actually counteract each other. So it's one of the things we want to consider when we talk to our techs is this impact that they have, to really start nipping away at it, and with everything they do to build into it this background that they're trying to drive towards energy conservation and sustainability. I'm trouble mixing those two phrases up, but it's all right. So anyway, part of this is, we want to get this into our technicians, so it's part of what they do day in, day out. And we also want to be able to call it out and take credit for it. We want to elevate this profession to trades, because it needs to be elevated. Too often, and Bob and I have talked about this over the years, where it's this four-year college type of mentality, as opposed to, hey, let's get a education that will get us into a good paying job quickly, which is technical schools, right? So we need to elevate that profession in the eyes of the population as a whole, because it deserves it. What we do is very important. It has a huge impact. So we're going to go through some basic classes and control classes that Bob and I both use for teaching energy conservation and sustainability. I approach this from a different perspective. I'm a mechanical engineer by training, and I have a lot of background in that. I've done consulting engineering work for, I don't know, 30, 40 years. So I have this approach that's not necessarily the hands-on approach that Bob has. And he has this hands-on approach of being a technician, having gone through all that stuff. And so when we have addressed this in our classrooms, we approach it a little bit differently. You probably see that in the way we talk about it. And one's not necessarily wrong or right, but the practical side of it, from my perspective, is really, really important. And I wish I had had that before I got in my other education, so I had a better understanding of it. We're going to go through some worksheets. We're not necessarily go through them, but we'll have available to you worksheets and some methodologies to help you with bringing this into your classes every day. So what are we looking at? Well, teaching sustainability and energy conservation for me in building controls is, how does the building automation technician have an impact on energy? And so every opportunity I have, I'm talking with my students about that. And it's something where you look at, let's say, something as basic pump operation. Well, is that system balanced? Where's the balancing valve? Does that balancing valve make sense for the situation you have? And how does that impact energy use when that balancing valve is, say, throttled 60% as opposed to only 80 or 90%? That would be open, by the way. So everything we work with on the building systems, we try to talk about it in terms of not just how to best provide comfort, but how does that also impact energy conservation? Part of that discussion, and Bob, we figured I had about 20 minutes on this, right?
Yep.
So you want to be able to go through and as you're talking about it, okay, from a electricity basics, we're generating, and we've already talked about this in different presentations today, we're generating a lot right now with fossil fuels. Well, we got to bring into discussion the renewable energy aspects and how that's going to impact what we do and how that's going to change the type of things that we want to install in buildings. Discuss the need of reducing energy use and how that impacts sustainability. You know, when I was back in college, I was looking at this from a little bit different perspective in the terms of looking at the oil situation in the world, because this was the late 70s, right? And our limited resources on it, the impact that it has on what society is going to be doing in the future, the chaos that it can create when energy becomes restricted can be quite a huge impact on our daily lives. And we're already seeing that. At that time, I was thinking about it more in terms of reduced amount of resource, and that's transformed over the past 40 years into not just resources, but also climate change and things like that.
Ted, do you mind if I chime in here? Because I think there's a great point for that curriculum piece to really link to something, and that's when you start looking at how energy incentives, like, you know, closed cooling towers and heat pump systems that were put into buildings in our entire Chicagoland area during the 70s, when everybody was scared, you know, the price of everybody, I mean, not everybody was scared, people were happy, but everybody started getting incentives to move towards just electrical based things because of nuclear power generation, and the cost of the kilowatt was going to drop down. So we have tons of equipment out here that isn't made for our area. That's very problematic consistently. And I have friends that run buildings all throughout the Chicagoland area with that. And that's something I think that link for the students, you know, equipment can be based around what's ever being pushed in the generation that's being built or retrofitted. So that's a really cool concept there, Ted, you got going.
Yeah, and you know, ironically, at that age of my life, I was about 20 years old. I was thinking, well, do I really want to have kids? Bringing them into a world where I see all this reduced energy reserves and causing potential havoc around the world. So it was kind of interesting. And these are basic things that when you relate it to your students, they can understand this and start trying to put in perspective of what they do day in, day out. Again, we've talked about this a couple times today, but what does net zero mean? You want to talk to your students about that aspect, because it's kind of a hard concept to really understand. And people think right away, well, that means we're not going to ever have anything that consumes any type of carbon-based fuel. And that may not necessarily be true. For example, at MATC, we're looking at, and I use my school as an example quite a bit. We have signed on to a net zero agreement nationally, and that means we got to drive towards the school being net zero. How do we accomplish that? Talk through about the pounding that we're trying to get into as efficient of a space as possible. Once we got our efficiency maximized or close to it, we start bringing on the renewables, and renewables make up that difference. So trying to explain to them in more basic terms really helps a lot. When I talk about generation using fossil fuels and talking about basic electricity, I talk to them, okay, we have these different types of carbon atoms, they're different isotopes, and I start relating that to the type of carbon that we see in our atmosphere and our CO2, and why just looking at this basic balance of these three different atoms in the atmosphere, we can point to it's the fossil fuel is what's driving our climate change, because that's our greatest contributor to the greenhouse gas CO2 that we have. And we can point to the carbon, particular isotope of carbon that's up there, which is carbon 12. We're really increasing that quite a bit compared to the others. So I bring it into my basic teaching about electricity and generation of electricity. Thermodynamics, that part of it, I like to let them know that, hey, what we do is try to minimize that heat transfer. This gets back to the building envelope, and also get into refrigeration cycles. We want to try to impact what we do so that we work more efficiently from a standpoint of energy transfer, so we have to use less of what we pay for fossil fuels at this point for keeping our spaces comfortable. Psychrometrics, Bob and I were just actually talking about this before everybody came on, looking at just the air pressure in the area from weather. My scientists are giving me a little bit of grief right now and giving me a headache. I can feel it right up here. And Bob said, well, it's because you guys had this pressure system that's coming in Wisconsin, and that's probably impacting you. So just talking about psychrometrics and partial pressures and how that all impacts just what they do day in, day out, and how they can relate that to trying to minimize pressure differences, trying to use that air when it's available and economizer to save energy, all these different aspects of psychrometrics that come into play with controlling your airflow in a building.
And you have to tell them that I watch Wisconsin weather only because I'm looking for snow going on the snowmobile trails. Selfish, purely selfish.
Yeah, I'm selfish. I'm envious. You got more snow up by your cabin than I do here in the Milwaukee area. So, getting back to the basics about what we talk about in classes, I look at when I get into the higher level control theory classes that I teach, we talk about scheduling. We talk about a little bit about ASHRAE 36, how that can come into play, which I know there's lots of issues we need to deal with on that, but it's something that's helping drive us to be a little bit more efficient. And bringing that into our discussion and why it's important is critical. So that's a good way to bring in sustainability and energy conservation. Properly designing, installing, controlling, and maintaining all types of systems is really critical. And this is something that we have a huge impact on. Maybe not necessarily always involved with designing, right? But what we're training our people to do the installation work, controlling, and maintaining of all these system types. And there's so many opportunities to talk about raising a red flag when you're installing a piece of equipment that you know is way oversized for the application, that may in effect waste resources initially because you're using more materials, bigger equipment and stuff and cost up front. And on the long run, that larger piece of equipment may be less efficient in providing what the space needs. So there's stuff there we can talk about. Controlling, there's so many aspects of controls that will allow us to cut back on consumption, and we can bring in that sustainability aspect. And of course, maintenance. I've done some work where I did a study on half dozen buildings where all we did was just provide those half dozen buildings with a very basic maintenance plan, and they had to follow that plan. Well, when they did, guess what? They saw a reduction in consumption in their buildings by 6%. And that was just being aware of it, period. So it's you know, those basics are really important to drive home with them, that they have a huge impact on what their building does and how it consumes energy. So
Yeah, we'll keep moving. Yeah.
Going with HVAC techs, power engineers, these are the type of people that come through the programs that I teach. They're all involved with this stuff. So let's call it out, take credit, elevate our profession. And I mentioned a little bit about basic electricity class. We have a course that teaches electrical concepts and control theory 1. And this is where I talk about the CO2 I mentioned earlier, non-fossil fuel generation methods. These are just an example of what you can bring into the discussion. And I think most of us have some type of course in our curriculum that teaches basic electricity. And so you can bring this all into play. And with anything about what I'm mentioning, what Bob's mentioning, if you're going, hey, how can I bring that in? Just reach out to us, you know, down the road, and we can bring some of our examples and give you some feedback on things. Okay, this is still mine, huh? So I'm teaching measurement and verification, which has a huge energy conservation component to it, because that's what a lot of the measurement and verification protocols were developed on, was for the importance of being able to validate energy savings. So I talk about that. Commissioning is efficiency. And I teach a commissioning class, but you might just have commissioning as part of one of your classes. And you can give an example in that class about how commissioning a particular system can benefit from not only operational standpoint, but from an efficiency standpoint and health standpoint in the spaces. DDC controls, they save energy when done right. Critical that people understand how to use them. Another example I came across, I was involved with a dozen buildings where we installed just a hybrid control system. So basically overlay DDC onto pneumatic system. This is back in the 90s. And we monitor those dozen buildings. And over time, we were able to show that they had over, on average, 12.5% reduction overall in gas and electric, just by putting that initial front end DDC system on. So driving that home with them, that these basics are really important to save energy. Maintaining systems properly, critical. I think properly maintained systems can save you anywhere from a couple percent on up to 10+% in energy. I talked a little bit before about balancing of the water systems. Same thing goes for the air side of it. Anytime you throttle something, you're wasting energy. So you want to minimize that throttling. So it's really critical to set those systems up. And this is something where, you know, the people that Bob's program has, they're going to be doing more of that balancing in water and air systems. And so they're going to need to know that that is an important part of what to do, is to minimize that throttling, to reduce consumption, which ties directly into VFDs. The whole impact of VFDs is to be able to meet the same load with a slower speed, and therefore have a huge impact on energy efficiency. So we get into the fan laws and why that reduction of power is cubed, basically inverted cube relationship to CFM flow. And then that really drives home with them that they have a huge impact by making sure that those VFDs are operating properly. So control sequences, you know, they have a huge impact on control theory and control theory courses. And I give an example of a building. This is actually the building I'm in. They basically in 2016 decide, oh, we're going to really tighten up the schedules in the building, really make sure that our set points are holding to a standard. They made sure that you drop them all down to 68 degrees because they're all over the board in all different areas. Well, they did that right around, you see right above the, I don't know, can you see my cursor?
Mhm.
So at this point is where they started really hitting that hard. You can see it just start dropping ever since then. And that impact of just doing simple things on the HVAC system, because the people who were working on it, they only had access at that level, but doing those simple things really had an impact on energy conservation in the building. And it really hit hard on the gas side of it. You can see that there was this significant drop. The red line is heating degree days, and the blue one is the actual gas consumption in the building. And their simple measures really had an impact, dropping it way below the degree day, because degree days in the past were where I set up on the graph, so they basically overlaid here. You can see as it goes forward, they separate. So showing them things like that. And this is also, I tie this into my energy auditing class, where we grab this data and we have them plot it out and show them how they can verify that things are actually having an impact. We already touched on economizer controls. Bill Banfleth was talking about the trade-offs between healthy buildings and energy conservation. And one of the examples I give that is back in the late 70s, my industry, which is energy conservation, did a great disservice, I think, to especially schools, where we wanted to close off a lot of windows, insulate those spaces, so there's less heat loss out of the room. Well, this has a negative impact on the space, the comfort, and the well-being of people in the space, and that's really not sustainable for that building and the people in it. So there are these trade-offs that we have to consider. Today we're talking more about the IAQ ones, right? But still, it's things we have to watch out. I mentioned about ASHRAE 36 earlier.
So
What's that?
how do we get there, right, Ted? How do we get to understanding stuff, what you're teaching from a control perspective? Everybody always sees this high level thing, and how do you get somebody that's coming off the street, that's coming to an HVAC program, to start understanding any of this stuff? And there's a lot of different ways that you can start to do this, and you have to first gravitate towards the foundational energy concepts that are going to be practical enough to your classroom, that are going to make sense of the absolute crazy complexity of HVACR. And natural gas and electricity, believe it or not, I try to teach fractals, the reoccurring themes that you see again and again and again. And our infrastructure of transmission and distribution, whether it be natural gas or electricity, is very similar. How we increase the pressure, and you can start having pressure conversations with folks, but at the same time, you could teach the infrastructure piece. So natural gas being transmitted, you know, up to the thousands of PSI, and then dropping down to 30 to 100 PSI on the distribution is no different than, you know, 500,000 volt power lines that transmit across areas and drop down to, you know, 240 volts at your home. So when we go into those things, you have to talk about how did we get here, and how to look at what does our national infrastructure look like in an overview, not super complex, but they need to know that we have different transmission organizations that operate, whether they're independent or regional transmission operators all over the country. And if you're going to teach anything about energy, one of the first things they need to understand is our grid, because that's most of the problem with what's going on. You could dig into things like FERC Order 1000 and everything else that exists out there that, you know, allow renewables into our grid. But the cold, harsh reality is that if you don't understand the difference between base and peak load, you're never going to wrap your mind around why we don't have solar panels in every state, everywhere, or Wind turbines. I'd say windmills if Chris Miller was on this conversation right now. But we have an issue with that. So you have to understand our infrastructure and what its capabilities are. And it also leads you right down the hole to smart grid and the DC interconnection of our grids. And when you look at, line losses, I believe in climate change. It's changing, shifting, whatever is happening. Do I necessarily believe in electric cars that they're going to save us all? Well, maybe later. I just don't think our grid's built to deal with the amount of driving us humans do on a daily basis. I don't think we have an infrastructure even near it for the next 20 years. And if we can localize power, that's one thing. But I have these conversations with students and I say, look at electricity compared to gasoline. We have something that wastes 70% of its energy and waste heat. And then we transmit it at 18 to 22% more loss. And you weigh that in on the whole equation, and we're at 22 to 26% efficient electricity we're plugging into our cars. And when you're writing about how bad these energy companies are, that are demanding this on your iPad at night, opening your refrigerator and taking a 50-minute hot shower, it's a personalized problem. And energy starts with every single human being that exists on planet Earth. And we all have a sustainable responsibility. And you have to make that very clear to people, because there is no magic answer to any of it. And that's the reality. And that's where you can start moving into the responsibility of, a technician. A technician is probably the number one go-to expert. That's an HVAC technician for energy across America. Why? They're managing everybody's systems of everybody's home, whether they're wasting way too much energy, or running just completely inefficiently. That's something a technician has to spot. There's too many systems. There's systems within systems within systems, and there's more complexities. And
and that's where you look at it.
Yeah,
HVAC is the largest load in our buildings, right? And
exactly. So you have to teach that the role of that technician in regards to that energy and sustainability, and you have to show them what the true cost is. Do you want to stop taking 30-minute showers? Do you want to stop? Look at the plug loads. I mean, I love the one presentation that was just done on plug loads, 2 years ago over at the lab. It was wonderful. Just what we gave up one thing, we're getting more efficient, but we're adding more. So go ahead, Ted, and transfer on to the next one here.
All right.
I'm moving to one of the classes.
I was going to make a comment too about the
Sure.
Grid. And one of the things that I constantly bring into my discussion, whether it's in electrical concepts, part of my classes or others, is looking for inefficiencies. And there are places where you're changing energy forms. And the grid does this a lot. We're changing from whatever's generating that coal to DC or AC power coming off the generator. Then we have to get that AC power at 10,000 volts, say, transform it to whatever voltage we're going to transmit it at, anywhere up to 500,000 volts, right? Every time we do that change, we're losing energy. And I use that as a way to show inefficiencies and drive home how we can do this better. You talked about the cars too, electric cars. And one of the examples I use, I can compare a regular car with gasoline versus an electric car. And I haven't done this for a couple of years, so I'm not sure I have the numbers exact. But the electric car on a percent of input energy back at the source is more efficient than a gas powered car. It's one of those things where you look at the numbers and you show them this, and they start to realize, oh, okay, these things make sense. These are where all the inefficiencies take place, and I got to look for those when I'm working on my equipment to minimize that inefficiency at those points of change from one form of electricity to one form of energy to another form. So,
but until it makes sense financially,
and that's another whole
it'll never work.
Yeah,
and that's what it comes down to.
Yeah,
and people worry about their personal finances, and everybody's definitely entitled to. So
Yeah, it's primary on everybody's mind, right?
exactly. So in our electricity class, one of the things that they really need to understand is that, when I teach it, I teach the basic concepts of magnetism and heat. I do not agree with technicians being educated by classical electrical engineering. I make that very, very clear to them throughout the entirety of that class. People just need to grasp the concept of electricity first. And you have to stay on a much simpler version of it. And I think a lot of people are just lost. And, it's like equipment that gets sold. It's all the same stuff. You're just talking about a different version of it for yourself. It's like a refrigerant being sold. You can say whatever you want, but it's just a pressure that relates to a temperature. And that might be an oversimplification, but to take something that's that complex and you don't simplify it in a technician's mind, they'll never truly understand how it actually affects the energy and sustainability of our world until they truly grasp that concept. So, the national electric infrastructure and generation is a big part of the electricity class and how it gets to our home. And then obviously its role in HVACR. Its role in HVACR is everything, and what we use, and control voltage versus power voltage, and what we're using and how to look at everything, right? Yeah, I definitely, Robert, I'll get to that at the end. That's a great question. But why HVACR technicians are responsible for energy is very important. You can go back to the heating class. We can just get to it because it's going to go into it. So heating class, everybody talks about the kilowatt, and it's, you can talk about electricity and that. So I've always been one who, I went through an entire program and I knew what BTUs were. I could say, oh, I have a 50,000 BTU furnace. Well, why do you use a higher efficient one? Well, what's the world's answer to it? It's the same thing every other greenwashing person does in the world. It saves you money. Is it necessarily true? I don't know. When you look at the cost of capital and the internal rate of return, and you look at it like a true investment and you weigh it out over the cost of 25 years, no, it doesn't save you money when you really look at it. But it costs less a month. It's better on the environment. And you have to understand, how much does this furnace cost me a month? And I couldn't ever get anybody to answer a question, so I had to go figure it out myself. And the questions that I have attached, I have like a 5-part series of questions, and you'll get to see it. There's a link Ted's going to put in the chat, I believe. And they're over 5 weeks. I take them through energy calculations, and you have to understand a watt versus a kilowatt and how to convert. And, people in the HVAC program, there's some that are great at math. There's some that are bad at math. I've seen people that are great at math just not wrap their head around the concepts of the story problems. But you want to start getting to think about a BTU and what is the actual cost of a BTU. And we do that by comparing furnaces and the efficiencies of furnaces to each other. Not only the efficiencies of furnaces, but we look at electric versus, natural gas. And when you look at the cost of it and it's 5 to 1, well, of course, everybody's going to use an electric furnace. Now, I've been hearing heat pump again today, again, and again, as an answer. That's an answer in certain climates, but not all climates. And when people don't understand, the miscibility of oil in a vapor compression system and what happens in weather swings and how that all has to be managed and controlled, otherwise you destroy your equipment, well, that's another story. And, you have to really start at ground zero. Every watt is 3.412 what? BTUs. And, when we look at kilowatts, what are we looking at in BTUs? How do we get from one place to the next? And I have some examples of some questions. I'll go into those in a minute. And we'll take a look at it. The next big concept is what's combustion and its effect on our world? You know, here you can even look at nuke plants. Well, you know, you get more radiation living next to a coal-fired power plant than you do a nuke plant. Who would have thought? Well, obviously, unless you're near Chernobyl, right? Or 3 Mile Island. But, you know, what's combustion and what's happening when we're burning these gases? And, you know, we talk about sequestration and capturing, you know, and scrubbing and air scrubbing. You can start your conversations there, but it all comes down to one thing when we're capturing waste streams, and that's the true meaning of economizing, right? What's economizing? It's capturing waste streams. It doesn't matter if it's, you know, a condensing furnace. It doesn't matter if it's capturing the waste streams for your feed water on a boiler, whether you're capturing the heat off of blowdown, you know, on something. You know, it all comes down to how do we capture waste streams, and don't overcomplicate it. You know, everybody tries to make up these things like these are very different. No, they're not. They're the same thing. They're capturing waste streams. And the more we try to complicate things in the world, the less people will ever truly find focus in to understand the fundamental. And that's what it's all about in a core class, in a program, and it's guiding them towards fundamentals. And, you know, one of the labs that does it well, you can either clock a furnace or an air conditioner if you want, but clocking a furnace is a neat way to look at natural gas. And we have gas meters set up on 7 furnaces. And I have a lab attached to everyone if they want to see it. And it's how to clock a furnace. You know, you go through and you're looking at how much natural gas are you using. You're looking at your input, you're looking at your output, and you're seeing where you actually stand. And there's 2 ways to look at it. Play with the airflow, play with the gas valve, and derate it. And those kind of things, after you have that energy discussion or while you're having it, start to get them to understand. And one of the big ones I didn't get into as much as, but what's the difference between that electric furnace and that gas furnace? But how do I translate that kW, a 15 kW kit, and understand even what it means? When I was a technician, I first got out of school, nobody said, oh, it's about 50,000 BTUs on a furnace, right? And it's 100% efficient. It just costs you 5 times as much. There's the dilemma and the paradox we all live in with energy forever, right there. It's a cost paradox, right? And
yeah, that's an example I come up with all the time, Bob, where I've been watching the price difference on a BTU basis between natural gas and electricity for the past 35 years, something like that. And
yeah,
the ratio historically has been about 2 to 2.5 times more expensive for electric compared to natural gas. But since about 2008, we've been dealing with factors of 7.
yeah.
From 7
Unless you're in California, then it's way worse. But they don't have to use as much. They got a nicer climate.
We're in Wisconsin, so I'm quoting Wisconsin.
Yeah, exactly. So let's go to the next.
4 times.
Let's hit the next slide here real quick, and then we'll show them some examples. So just assignment examples. This is just some of the problems that are out there. But all the problem pages that you can download, they all have, you know, Ohm's law stuff. They have all the gas laws. They got the conversions. Might be a typo here or there, whatever. I try to look them over, but you'll see them on there. But I mean, you start with basics, and then you're moving in. What do we have? We have a 30 kW heater, and you got to compare it to a 96,000 BTU an hour furnace. So then I'll start playing with these furnaces, and I'll do an 80% furnace, which one's more effective. And now we're going back to combustion. So now they get to truly realize it's weird. In these problems, you can get them to realize in these problems with 80% to 95%. Well, where's the other 5% going? They think that they have a 96,000 BTU furnace and that's the effective heat you're putting into the home. No, you get to show them how you dismiss it, and that energy is going out the stack. That's what efficiency is all about. And you really get to bang home the concept of efficiency. And you start comparing them. Well, which one has more energy? And you start playing with the numbers that way with them. Now, again, people think that I've had my worst students get through this. maybe I should go teach developmental math. I don't know what it is, but I'm just telling you, you can drag them through it, whether they like it or not. I don't put hard grades on it. This is to teach them and educate them about energy and how to see it at a cost level. Because everybody understands a dollar and they're going to deal with it the rest of their life, whether they like it or not. They're going to deal with therms or cubic feet of natural gas, and they're going to deal with kilowatts. So they might as well learn it now. And I always teach conversions just because of controls. Because if they buy something from Europe, you know, we got to deal with that, whatever. This is America. We deal in Fahrenheit. So anyway, go ahead, Ted. You can go on to the next one.
Okay.
So, all right.
So that's question time. And Jen just brought one up about, you know, we do a good job talking about connecting with HVAC. Students.
Robert's going to be mad because he had the first one.
Who did? Well,
here, we're going to go up.
And we'll go back
Ann
up.
said it was snowing all day, so maybe she was on the button first. But Robert said, Bob, can you explain what you mean by disagreeing with technicians being taught classical electrical engineering? Robert, the number one thing I see when I have new adjuncts coming in is they want to spend the whole semester teaching Ohm's law and 8,000 equations. Those teachers never make it back the next semester. Why? You can use Ohm's law all you want. Using a meter and effectively being a technician means you have to be able to use the meter, not just talk about Ohm's law. And Ohm's law in a consistent world is there. And we start talking about the stuff that we deal with in dynamics, right, of AC power, it changes everything. And one way to understand that is with your meter. I want them to be able to effectively use an ohm meter, a voltmeter, understand the difference between AC and DC, understand the difference between 24 volts, 120, and 208. Because as you will find out or already know, everyone thinks 208 volts power needs a neutral somehow. The evil neutral that has screwed up the minds of all of our children. And they will never truly understand electricity and the power of induction through a transformer and what it actually means when you break it down the correct way. And the folks that get into VA and overcomplicate transformers, it bothers me a lot. And if I ever wrote an electrical book, I completely changed the game on it because I do not believe in how traditional electricity is taught. And anybody that wants to compete against my students, I'm willing to put my worst one against yours.
No, thank you.
No offense. I'm not trying to be mean or confrontational, but I want to show efficiency of a technician.
Yeah, I agree with that. So
You got another question.
yeah, what Jen had asked was, we're doing a great job connecting HVAC to sustainability. She wants us to flip that. Okay, how do we get those interested in sustainability to go into HVAC? And I don't have a good answer for that one because, you know, I guess it's just a matter of trying to give them options. That's the only way I could see it.
Well, it's interesting that Jen brings that up because when I look at the renewable of solar thermal, when you look at solar thermal and you try to wrap your head around it, when you take the majority of HVAC technicians that are clueless when it comes to hydronics, and then now you take somebody that put a solar panel in or a solar thermal panel in and thinks that they're going to effectively control it, everything comes down to control, whether it's digital, whether it's mechanical. And there's a huge lack of hydronic understanding. And I think that's one of the main reasons why solar thermal suffers the way it does. It's because people just start thinking it's not working. Well, it probably does fine. Just folks don't understand hydronics, period. And and I'm not trying to say it in a bad way, but I've been in a room full of, 100 engineers that design buildings and stuff, and they all have a different perspective. They can't agree on one thing. and they want it all to design it a different way. Well, maybe one way is better for a particular building. And that's the difference between HVAC and, automotive. Automotive is one thing, is the same thing, the same way for all of it, right? It's a car built the same exact way. Every building has got something different, and a gazillion contractors work their way into it and mess with everything. So who knows, between the sheet metal, between your pipe sizing, between your pump sizing, between impeller sizing, between your balancing valves and what type of authorities you're going to grant yourself. I think, I don't know. I think sustainability, I don't think that's a far sale for HVAC. You're in charge of all energy in somebody's home.
So Sean made a comment about this too. He said that 40% of the world energy use is in buildings, and most of that energy use is used for HVAC.
Same as what you just said.
What was that?
Same as what Bob just said, basically.
Yeah. Yeah, and I mean, I think that number could even be greater. So yeah, it's on how you want to look at it. And then you look at facility technicians. Well, what are they in charge of? They're in charge of the electrical systems. They're in charge of the HVAC systems. They're in charge of, all the faucets that stay on 24/7 because the batteries are low. I mean, it's another thing. I mean, we had people at our factory chasing around. I try to tell them, obviously, lowest hanging fruit, that's the name of the game, and the whole world gravitates towards, well, let's change the light bulbs and the ballasts and let's hit the low hanging fruit. And well, what about the huge motors that are running 24/7 a day? What about your chiller set points? What about your air handlers? These devices that nobody understands, that live in the bowels of every building, that still are neglected. And the no accountability and audit trails for commissioning. When are we going to have a standard there? If you want to talk about it, and that's HVAC, that is us. So I don't know. There's endless opportunities in HVAC, endless, and companies are created overnight, and they will continue to create overnight and other twists. The one thing that, I don't think everybody should stay away from is, when we put energy efficient things in, like DRS systems and that in school systems everywhere, and it's on the taxpayer dollar, they're all serial networks. When are we going to start teaching serial networks? When you look at automation and controls. So, while it's a great technology, the second that serial network starts to break down, all your equipment's not working the same way all at once.
So JD, you had a suggestion, and I don't quite understand the wording of it. Maybe you can better explain it.
Hi, so for some people, math is just totally intimidating, and you get started, and all it takes is to get one fraction inverted the wrong way, and then you're multiplying the wrong direction. So there's a thing called dimensional analysis that would be really helpful for the technicians that are, if you've got amps per second times seconds, then the seconds cancel out and the result is amps, for example. So a lot of times you can check to make sure you've got the right equation just by putting the units there and checking to make sure that they cancel out properly. It's called dimensional analysis. It's got a fancy name, but it helps people make sure they've got the equation set up right.
I was doing that. I didn't realize I did do that. I always, when I'm putting up the equation on the board, do my crossing off of the units so that people can track through, watch, make sure they have the correct end result.
Just getting them to write it all down is the hard part, right?
Yeah, that's the really hard
pipe fitting. Pipe fitting's horrible like that. If you don't watch the details, you're done. And I see that a lot all the time. And I warn them in the beginning, and then I let them suffer and fail, and I drag them through the mud until they actually want to listen. And then they start writing it all out, and then we can make sense of where they're going wrong or dimensionally analyze what's happening. Yeah.
I'm not seeing any other questions. Anybody got some? You want to just open up your mic and ask away? Go ahead.
For us dummies, can you explain what clocking a furnace is, please?
So if you went out to your gas meter right now at home, and there's actually, well, wait, do you have a gas meter? Let me ask you that. Let me ask you that.
Yes.
Okay, all right. So I don't know. You might, I don't know what climate you're in right now, but clocking a furnace, if you're going in, you're looking at, how much energy that furnace is using currently at that moment. And you can do it by going out and look at the dials on your gas meter. You can turn your furnace on and you can count the seconds of how long it takes for one of the hands to go around and do a little bit of math, and you could find out how much energy you're actually using. So clocking a furnace is like, clocking somebody on a 40 time. You're just seeing how much energy that furnace is pulling, to go around one time, how many seconds, and then there's a whole formula that goes with it. So it's basically seeing the energy use of your furnace if you're using natural gas.
Great, thanks.
And I'm going to put that one into my classes next time around. I really like that idea. Give them a little bit better feeling for what they're doing.
Yeah, it brings home gas usage and everything else. I think temperature rise, I think, is the most important, but that's a whole nother long discussion.
I agree with Bob completely when he talks about reading their meter and understanding what their meter is telling them before you can even get into the any theory behind it. And even then, you only need to go so far into it, into the engineering side of it, because for a long time I taught AC all the way down to finding angle theta and all of that, because that's how I was taught. But then I had to sit down and consider, okay, at what point in my career did I ever use angle theta and that kind of thing? And I didn't have an answer. And I said, so why am I confusing the hell out of my students?
Robert, I saw a student measuring voltage one time after I talked and did the "Oh Captain, my Captain" speech upstairs, and we went through every equation under the sun, and they measured voltage by putting the clamp on meter, or measured ohms by putting the clamp on meter around a wire. And I thought to myself, this isn't right. They don't know. And the most important thing is, when I see him, I always make fun of him. And I said, it's like Ricky Bobby in Talladega Nights. When he starts raising his hands like this, what do I do with my hands? And it's like them with the meter leads when they get the meter leads out. And they're like, where do I put these meter leads? And where do they go? And they don't understand. The most important thing is how to measure something in parallel, besides finding the potential difference of something. And you can really drive those things home, and you can move into the concept of bonding and grounding and things that, I have teachers interview that are electrical licensed that are clueless when it comes to bonding, clueless and grounding, and don't really get it. And it's not that it's a hard concept. It's that everybody's classically educated with this calculating engineering mindset. It's that the engineers all come in and they're trying to figure out this huge problem. I had plenty of problems like this when I was in industrial maintenance, where, the boxes keep falling off the thing, job's not going. all the king's horses and all the king's men are there, and then they hire an outside contractor to come in, and he says, give me your hammer, and he grabs a hammer and he swings it, and he hits doing all the calculations in the world, this guy swings a hammer at a roller, and the boxes don't fall off anymore, and it goes straight, and business is back on. And he goes, that'll be $10,000. Well, and he goes, $10,000, you swung a hammer. He goes, I only charge you $50 for the hammer swing. Charge you $9,950 for where to swing it. And don't ever forget that. And I want my students to know where to swing the hammer. And whatever gets them there the fastest, that's the route I'm going to take that's going to fuel their success. Because that's what I look for and judge myself on at the end of every semester is how much did they learn.
As far as energy conservation and energy literacy, the thing that I started to use is the power bill and the gas bill. How much it costs? What's coming out of your wallet? That seems to get their attention the quickest. And I have a horrible building. And my power bill for my campus is insane because it was built in 1976. It had an upgraded hybrid system put in the early 1990s, and it was never maintained. So now, when it's too hot inside, they turn the chiller on, and they manually move dampers to whatever classroom needs cooling. The chilled water pumps are manually turned on and turned off. The boiler is manually turned on, turned off. Hot water pumps are manually turned on and turned off, and all of the valves are manually positioned with little blocks of wood in their valve stems and everything. So we were going to get a contract to get that replaced, but instead they worked on the lighting.
Low-hanging fruit, right?
The lighting.
Low-hanging fruit.
Yeah, low-hanging fruit. And so, but I have these power bills that I can get, and I also look at residential power bills because, like, depending on where you are in this area, certain areas they only have electric because they can't get gas piped to them because of the way the terrain is. It's swampland. So if you're in Tangipahoa Parish, most of your gas furnaces are going to be electric, whereas if you're over in Livingston Parish, all of your 80% gas. You have 80% efficient gas usually, and so they don't turn the heat on often. Maybe 3 days a year they'll need to have the heat on, but they'll have gas hot water heaters and that, and so you can compare. Okay, clocking the meter is the thing we show them. What's it going to cost you? How can I trim the cost off of this?
So what you're saying is, fortunately, we all work in government where they efficiently and effectively utilize every BTU.
But it's
great learning opportunities.
It's a great teaching tool.
Yeah, they are. They really are.
Couple of side comments here. Can you guys hear me?
Yes,
Yes.
you hear your Paul.
Okay. Couple of things. As a classically trained electrical engineer, I fully understand what you're talking about. I want you all to know I haven't used a Laplace transform in the 50 years since I got out of school. And there's a whole kinds of things. Ohm's law, basic things, knowing conversions. If you don't know something, figure out where on the internet you can get it. My job now is to do all of these kinds of jobs. A couple of, it's you're not going to know it all right away, and you're going to have to figure it out yourself. You got to know common sense, instill in the students to use their heads. What seems right? What do you think? It may not be the right answer, but the 5 whys, those kinds of things. I run into situations constantly where I don't know, and a lot of them, go beyond building HVAC. Some building HVAC systems are basically their processes. They generate so much heat in the process, they never have to cool the building. So now you have an excess. Where does it go? How can you use it? You know, try to get things turned off like you guys were talking about. There's all kinds of things, but I think the thing that you instill is you're not going to get it right away, but big crossover to sustainability, a big crossover to dollars. Management isn't going to understand what you're talking about. They're worried about widgets. If it's an office building, you're going to have, each office is going to have 20 different comfort zones, depends upon who's sitting at what desk. You know, there's all kinds of tie-ins and all kinds of things. My journey started kind of late in life, and Ted was a major factor in trying to get me going. So Ted, here's kudos to you and MATC. But
Thanks, Paul. And I want to let everybody know here, Paul, I've used your picture of the bill analogy for power factor and reactive power. I've used that for the past, I don't know, when did you give it to me? About a decade ago now?
Yeah, at least.
So this group has seen it, or many people in this group have seen it a number of times at the Best Center, because I put that same picture up a couple times there. So that's my source, Paul.
So yeah, one of the things that I don't know if you guys can kind of see this, try to get it, and this is something that I got from Ted upon graduation from a course. But a pound of coal is a kilowatt hour of electricity, 2.5 pounds of CO2. It kind of says it all there. There's your whole sustainability question. So the question is, electricity at 26%, I think somebody made the comment, you know, is it better? There is no right answer. And I just wish I wasn't quite so close to retirement, because I think the next 20, 30 years is going to be a heck of a good ride. And everybody in this kind of business should have a lot of fun. So the wise old wisdom, and I'm done. So
yeah, on that note, we're at 4:01 or Central Time, so it's 2:00. So
Who's disciplining us right now?
What's that?
Kim is disciplining us right now.
So
She's sending nasty grams.
That's the end of this session. If you want to hang on and talk some more, we'll hang around. But thank you everybody for coming. Good information.